Hello guys, once again. Now in this section we're going to talk about quadratic inequalities. So quadratic inequalities, it's like when you have a quadratic expression followed by an inequality sign. It can be greater than, smaller than, greater than or equals to, smaller than or equals to. It doesn't really matter. You have your quadratic expression. Then you have your inequality sign, then you have another expression, and that other expression could either be a constant or just an expression. So you're trying to solve the values of x where the whole statement will be true, right? So let's get into it. For example, we have this question. Oh no, go for red. So this is our expression, right? And it's a quadratic expression, x squared minus, So now you have your inequality sign, which is smaller than, and on the right hand side you just have a constant 12. We're looking for the values of x, whereby that expression x squared minus x will be smaller than 12. In other words, you are also solving for the values of x, whereby this expression will be true also. X squared minus x minus 12 being smaller than 0. And since we're trying to find the values of x where this is smaller than 0, we are trying to find the values of x where the expression on the left will give us negative values. All right, let's get into it. So if you have a problem like this, or you have a quadratic expression, I'll just say the next thing you can do is to solve it. No, not solve it, but say we take this inequality sign and we make it equals to, and we try to factorize that. Factorizing the whole expression on the left, that will be x minus 4 x plus 3. How did I get 3 and minus 4? 3 and minus 4 are the values that if I multiply them I get minus 12. If I add or subtract them I get minus 1. So so you have that expression, and from this expression you can now do what? Draw yourself a timeline, where here say you have minus 4 and here say you have what? 3. And of course maybe here we could say this is 0, x equals to 0, right? So you have 3 regions here. Oh my god, I need to learn how to draw this. Hey, cool. Not bad. Second expression or second region. Third one, right? So this is region 1, region 2, region 3. So in those regions we're going to substitute values, right? So on the calculator we have brackets, right? So now it's x being any value. Let's take any value below that is smaller than minus 4. Minus 10 for an example. Minus 10 minus 4, you have minus 10 plus 3, and what value do we get? We get a positive number. What does that say? It says any value that is below minus 4, and you substitute it in this expression. Wait, what am I doing? You substitute that value in this expression. Damn it. This expression right here, you're gonna get a positive value. Even if you go for minus 5, just for an example, I'll go with minus 5. 5 minus 5, we still get a positive number, right? So now the question is, let's take any value that is below minus 4, no, below 3 and above minus 4, right? Just any value between there. The easiest one is 0, it's just the easiest one you can go with. You get it minus, implying that any value in this region you're gonna get a minus. You take a value greater than 3, say 10, and if we take a 10, we get a positive. What does that say? If you look for values of x that makes the whole expression to be smaller than 0, we are talking about the second region, right? So now to answer this question, I will say therefore x is an element of what? Is an element of x is gonna be between between these values, and you're going to make those capped bracket, because of course our -4 and 3, they are not what? They are not included, yeah, they are not included, or maybe just in simple terms you can just say x is smaller than -4. No, x is greater than -4, and x is what? X is smaller than 3. Right, cool. Let's see what next problem. Let's take something quite easy. We have 3 minus t 1 plus t greater than 0. Like I said before, you have something like this already. The brackets are there, factorization has already happened. You take this guy, say equals to 0, and now it's like we are solving for what? We are now solving for t. And when doing that, you will see that t equals to 3 or t equals to -1. And given those values, the next thing we do is draw a timeline. Number line, let me say. Number line, you have -1 here. You have 3 here. And it's your 3 regions, of course. Yeah. And then we're gonna take those regions. We're gonna take our brackets. The first one, we have 3 minus, let's take any value below 10, below -1, that's gonna be, say, -10. -10, so you have minus, it's -10, and then we go this side, that's 1 minus 10. You get a negative value here, and if you take any value that is below 3 and above -1, we can just take what? 0. We get a positive value. We take values above 3. Let's say we go for 10, and when we go for 10, we get negative values, implying what? Implying that the region where we'll get this expression being greater than 0 is right here, where your x will be between what? -1 and 3. Right? Then you are done with this expression. You are done. So my computer is about to die. I'm just gonna note these few problems down. The next problems we'll be solving. Just gonna note them down before this guy dies. Yep. We're gonna copy this one. This is the first one we'll do. Paste it. Right. So solving this problem, let's see what we can do. Né? Of course, we already see x can never be 3, because once that happens, we will have something like x over 0, which is not real. So yeah, so to solve this problem, of course, the first if you just multiply the whole thing by x over x minus 3, like if we say x minus 3 multiply by the whole thing, x minus 3, yeah, you're going to miss out on other possible values of x, right? You're gonna only get like one part, for example. Let's just solve it for, yeah, let's just solve it quick. You get x smaller than 2x minus 6, and then it's 0. You have 2x minus x, you have minus 6, and then that's what? That's x minus 6, 0, and therefore x is greater than 6. So you only get this, né? But let's see. There's a method that I want us to do, which of course from this method we will get more values of x at which this expression will be true. Alright, cool. I'll just keep it there. Right, so we have it. First and first, transpose the 2. Right, after transposing the 2, then what? Trying to add fractions. We're subtracting fractions. Denominators has to be the same, so that it means here we'll multiply by x minus 3. Eventually you have x minus 3, 2x minus 6, x minus 3. Right, your denominators are the same. Now you can just subtract 2x minus 6, x minus 3. Right, and whoa, what is happening with this tab? Nice. So now what do you have? You have minus x, I believe, minus 6, right? And actually I did slight mistake. Yeah, I should have kept my brackets here. I will explain why. In fact, let me erase this part to show you that silly mistake. Be careful, guys. Try not to be like me and do the same mistake. So of course you have x, right? You have the same denominator right now. You have a minus. There we go. But now you take that expression 2x minus 6, into the bracket. Try not to forget that. Yeah, because from this case now you have x minus 2x plus 6, right, which is correct than yeah, than what I had previously. Now you have 6 minus x, and you have x minus 3 smaller than 0. Cool. So of which here, of course, one possible mistake would be trying to multiply the whole thing by x minus 3, where these are going to cancel each other, and you transpose x, and you are left with exactly what we had here, right? So when you get to this point, now you are going to use both of these both of these binomials. They're going to help us find the values of x where the statement is true, right? So for example, you would say 6 minus x equals to 0. That's where you'll get x equals to 6. And on another one, x minus 3 equals to 0. That's where you get x equals to what? X equals to 3, right? What am I doing here? This, it has to be x, right? So from this, from this time, you can just draw your number line. You have what? You have 3 here and you have 6 here, and we're going to try to substitute the values and see what we get, right? We're going to try and substitute the values and see what we get. So now you have your fraction, of course. You have 6 this side, wait, yeah, what's going on? Yeah, this side you have minus 3. So let's take values of x below minus 3. I can just say 0, minus 0, and then here what do I have? 0, right? I'm getting a negative value, implying that any value below 3 I'll get a negative, right? So now let me take any value above 3 but below 6. I will take 5. 5. So I'm getting a positive value, implying that here I'm gonna get a positive value, right? And now let me take any value greater than what? Any value greater than 6. Let me say 7. 7. And any value greater than 6, what am I getting? I am getting a negative. So I have a negative there. So I go back to my expression. Here it is. And that expression, it says that fraction 6 minus x all over x minus 3, it has to be smaller than 0, implying that it has to be negative. And I'm saying that that is going to be true only in places where my x is what? Is from negative infinity to what? To 3 and close bracket, and then union from 6 to positive infinity, right? So these are the values of x where that statement will be true, because with these values of x, the whole statement is the expression on the left is smaller than 0, implying that is equals to a negative number, like values from here going that way, values from here going that way, and there we go, we are done. So the thing is, if you did solve this problem using the first example, the first approach I showed you, like here, you was only gonna get the last part, you was only gonna get this last part correct, that your values of x are greater than 6, but now with the method that we did, we were able to get even more values. So have you done it the first way, in the first method, you're not gonna get all the marks, but with how we did it, you're now gonna be able to get all the marks, right? Let's see with with these examples, how far can we go. So I'll just say maybe this is 1 and this is 2. Let's do number 1. So number 1, of course, we see that x can never be 7, because once in 7 we have a denominator of 7. And yeah, you also realize that yes, electricity just came back. Whew. Okay, so you already see that I'm so excited because I'm hungry at the same time, you know what I'm saying? But okay, but yeah, we don't have any number. Let me write it down. That's x squared minus 4 x minus 7 greater than or equals to 0. We do not have any number on the side than 0. So let's just focus on the left, right? And like here, someone might be tempted to multiply the whole thing by x minus 7. Let me assume that I got tempted by that. I open my bracket, x minus 7. This x minus 7 cancels out this one. On the right hand side it's gonna be 0, so now I have x squared minus 4, let me just say minus 2x, greater than or equals to 0. Now I have a difference of 2 squares. I have a difference of 2 squares, which is just gonna be what I have right here, and now I have, of course, on my number line, I have minus 2, but then doing it this way, I'm gonna lose out on more numbers, right? Let me just stop right here, because in the method that I am going to do, we're still gonna get to this part. So yeah, let me stop right there. So the correct way to do it is, since we already have a 0 this side, I will rewrite it again. Let me say 2 squared this time, greater than, right? So you try to simplify your brackets, not simplify, you try to factorize all of it, and the numerator, when you factorize them, what do you have? You have x minus 2, x plus 2, right? Then you have x minus 7, right? So if you take this as an equal sign and say you're solving for x, you're going to have like 3 brackets. X minus 2 equals to 0, x plus 2 equals to 0, x minus 7 equals to 0, right? Now from here you can have x equals to 2, x equals to minus 2, x equals to 7. So now on your number line, you say that you're going to have minus 2, 2, you're going to have 7. So what does that mean in terms of your regions? You will have like 4 regions of interest. I'm getting better at this. But the first one, yeah, so region 1, 2, 3, 4. Now let's do what? Let's get into it. Let us get into it. So you have your bracket, and then denominator, we just have whatever minus 7. Right, so let me take a number below minus 2. I'm thinking minus 10. So here I will have minus 10, minus 2. I have minus 10 plus 2. I'm getting a negative value, so cool. Any value below minus 2 is a negative, right? Now I want a value between 2 and minus 2. Say 0. No? 0 is the easiest one. We could have also maybe taken 1. I do that, I get a positive value. Cool. Let me take a number between 2 and 7. I'm thinking 5. I'll say 5. 5 and 5. I am getting what? A negative value. Alright, and now let's go again and try a value bigger than what? A value bigger than 7. 50. And with 50, what do I get? A positive number, right? So now the question is, what is our expression? What is it we are trying to solve? The values of x, where the expression is true, in the sense that we are talking about this expression, right? And that expression, for it to be true, any value of x we substitute in that expression must make the expression to be, must make the answer of the expression to be a positive number or 0, So now we know that the answer is gonna be in this region right here, and the values are gonna be included, and here as well, so what does that mean? It means that your x is gonna be where, from -2 to 2, and they are both included, union from 7. No, remember, for 7 we cannot include it because our 7 is our denominator, which if x equals to 7, boom, you get a non-real number to positive infinity. Then boom, you are done. This is your answer. You have all the values and you are done. But remember, if you are done, have you done it just like multiplying x minus 7 throughout and therefore it disappearing? Remember, you're gonna have something like this, right? Of which in this case it was gonna be, we can copy from here, this was gonna be negative, positive, negative, right? But this one, it was going to lie to you. It's sort of, part of it is true, part of it is not, because somewhere on the number line, let me draw it again right here. So you have -2, you have 2, and this is negative, this is positive, this is negative. But from the work we just did now, we saw that at x equals to 7, from here going this way, you get what? You get positive values. But doing it the first method, you realize that it was gonna say from 2 going onwards, you're gonna get what? You're gonna get a value that is negative, which is not true, right? The whole answer and the right answer is this one right here. Let's do the last one. This last one is not gonna be a tough one, I will say. Cool. We know our x cannot be 0, so what we do, we're trying, of course, we are trying to solve this problem. Now let's make the denominator here to be x. So you have that minus x over x, right? And greater than and then now you have what? You have x plus 2 minus x all over what? All over x greater than what? 0. Now what do you have? You have x minus x, that's 0. So you just have 2 over x greater than, or equals to 0. So from this example, like I said, it's not a really tough one. X cannot be 0, so x cannot be 0. But for this expression to be positive, the values of x, they must be greater than 0. We cannot include equal to because of, yeah, sorry for that. Oh, yeah, blessed. So once we include 0, the whole thing becomes non-real. And then you are done solving this. In a number line, it would look like something like this. This will be 7, and of course your number line continues, and the line will just be like this. Yeah, actually, let me just say, of course, if a number is included, you're gonna have a dot. If a number is not included, you're gonna have this, and here, say here I have a 7. What am I saying? This is the same as 7 being included, going to positive infinity. And here it's just me having 7, which is not included, to positive infinity. So yeah, we are done with this section. Next time we'll be solving simultaneous equation. See you there.